So today I will talk about car keys, as we all know and use them, such a car key. More specifically on the remote keyless entry feature. That means the button that you press to open the doors. It's not about starting the car, that's a separate topic mostly. So we'll touch a bit on it. So this talk is based on work together with Flavio from Birmingham, where I'm working at the university. Work with Timo, Pierre, who was a master's student, and Andres, who also did some part on relay attacks that I will briefly introduce. So I know everybody has big expectations, so I will try to fulfill them. And forgive me if I occasionally step out of the screen. Car key, as I said, has in principle 3 security functions. One is very simple, mechanical blade. It's the top thing here, yeah? That you all know can be easily duplicated, so you basically can take a picture and copy these cuts here and make a duplicate of the mechanical key. Not very interesting from the computer science side. Second thing is the immobilizer. It's an RFID system running usually at 125 kilohertz. Uses in virtually all cases broken cryptography. So there are really nice papers, if you like, this legacy crypto attacks about DSD40, HighTech Tube, MegaMods. They're all broken, and they're only slowly being phased out. Yeah, so this part, to summarize it, immobilizers are quite broken, actually. What was less analyzed is this remote keyless entry system, which, as I said, is used to open unlock the doors or the boot of the car. That's an active UHF transmitter running at several hundred megahertz, depending on where you are and your car brand and so on. And in contrast to the immobilizer, it's a unidirectional system, so only the key ever speaks to the car. There's no transmitter in the car and no receiver in the key, just for cost reasons. If you know automotive companies, if you increase the budget by 1 cent, you need basically a justification for that. Usually, or traditionally, there used to be quite separate systems in the car key. So they could buy like the remote keyless entry system from one supplier, the immobilizer from a second supplier. There are also so-called hybrid chips that integrate this functionality sometimes, and I'll talk a bit about this at the end. So we were interested sort of in the security of these systems because they felt legacy when we looked at it, and we had some prior experience that you probably have seen last year when you were here, where Timo showed these key lock attacks on garage doors and so on. So how does the systems work? Used to be a very simple solution. What people said, okay, we just use a password. We use the fixed code, so every time you press a button, we'll just send the same secret value, basically just the UID and the buttons that you have pressed, your open, close trunk. And this used to be very popular. Sometimes it was not even with UHF, it was with infrared. And in very old Mercedes cars, you could take this universal infrared remotes for your TV and just record basically the code sent from your key and then open the car with the TV remote, which was sort of fun while it lasted. But I mean, everybody, I don't have to tell anybody probably in this room, it's a very bad idea to broadcast essentially a password over a long-range wireless channel. Somebody can sit there with some receiving equipment and from up to 100 meters easily eavesdrop the signals. That's like every time you sit in a train, type in your Google Mail password, you shout your password or enter it with Siri, basically. Yeah? So not a good way to do these systems. And the equivalent, or what an attacker would do, just eavesdrop, replay, and open the vehicle. So these systems, they existed in some cases even like until 2000 approximately. We found some cars that still had such fixed code systems. Maybe you have them even at home if you have such devices. Does anybody have this remote controllable power plugs? Yeah, they almost always fixed codes. You can sometimes see if you open these remote controls, here there are some dip switches, and you can just set the code and read the code. So quite a weak system and not of scientific interest, really. Industry has known this for a long time. It has invented the so-called rolling codes. And now comes the worst part of the talk, where I always have to talk about cryptographic key and key. So I will try to say always key fob or car key, meaning the physical device, and cryptographic key is some secret value that is shared between vehicle and car key or key fob. Yeah, it's programmed somewhere in the factory, for instance. There's, by the way, no asymmetric crypto. Yeah? So these devices sometimes have 4-bit microcontrollers. I didn't know that was still a thing, but there are 4-bit microcontrollers. So there's no way to run RSA elliptic curves here, not happening here. All symmetric crypto. And what they do is, they say, okay, we need to solve 2 issues here. One is with the fixed codes, you always have the same values, so we need to have some rolling code, some updated code. And also we need to put in crypto into it. And the way to do this, ensure, so to say, freshness of the signals is just that you have a counter, and on every button press on your remote, this counter is incremented by 1 and sent over to the car. And now the car can just check the freshness by having essentially a table where it stores per key fob, which is the last counter value that I've seen. And then if it gets a new counter value, it will say, okay, this one is newer, I open. If it's older, I don't open. Okay, so far so good. That would be freshness. And to now ensure that an attacker cannot just get a signal, then do +1, send it again, we need to put crypto around it. That's one way how it's often done. You just encrypt the counter value essentially and the button value. Sometimes they also use a MAC, which is the more correct way to do that. Depends really, but usually the systems look like this. So every time I press here my presentation remote, it increases the counter. And usually people visualize it on such a circle. So you have some codes into the future that are valid, but you can never go back with the counter. So if you receive an old counter, that's bad. Attack, replay attack. Why do we have this delta into the future if you want? If you go on vacation, for instance, and you give your key fob to your kid, and he or she plays and press, you know, then you want it still to work, even though the counter is now maybe 50 ahead of what the car has seen last, right? So there's always some window into the future, and if you really want to annoy somebody, take his VW key, press 256 times, and you're out of this window, and they have to go to the workshop, yeah, desynchronized. Quite annoying. Depends on the brand, how much into the future you can go. It's a nice magic trick in the pub. So anyway, the attacker is now unhappy. Oscar, the attacker, is unhappy. Cannot reuse old codes, can also not generate new codes due to this cryptography, because the shared secret key is just known to the both parties here. So Oscar is unhappy, but of course there are now attacks on the systems there as always. So otherwise I would not be here if everything was perfect. Last time Timo explained probably keylog in some detail, so I'll not bore you too much with the details of keylog. Keylog was such a rolling code system where keylog is a proprietary cipher, and there used to be first analytical attacks, which however required 2 to the 16 plain and ciphertext. So you would have to sit there while somebody opens his car 2 to the 16 times. That's how much? 65,536 times. And that's not really, really nice to say. Yeah, it's not realistic in a keyless entry scenario. What was more realistic were the side channel attacks on keylog key diversification from 2008 here from Bochum. They made at the time was quite like a big media thing. And essentially what they could do was do an attack on the receiver side, because keylog has a form of key derivation. So you have each remote control has its own cryptographic secret derived by the remote UID. But this manufacturer key that is used in sort of like an HMAC way, if you want, to derive this device key has to be in every manufacturer in every receiver of one manufacturer. So was at the time always go to Bauhaus, shopping, buy a garage door opener where keylog is very prevalent, extract the manufacturer secret, then return of course the receiver to get the 50 euros back. And then you do that n times. How many manufacturers are there in the world? 10, 20, 100, I don't know. And recover basically this manufacturer key. Yeah? So a clear single point of failure here in the system design, and also a very nice example for a side channel attack in practice on a real system. Yeah? So back in 2008, people did this and recovered all these manufacturer keys. And there were some rumors that keylog is used in many vehicles. turned out, at the time the manufacturer said, no, we don't use keylog, we are much better, and now in the rest of the presentation you will see how, to which extent that is true. What is true is they don't use keylog. Another thing I want to briefly mention are these relay attacks. They have been in the media quite a lot on passive keyless entry systems, so don't confuse them here. Passive keyless entry systems are for the people in the room who have expensive cars. They don't want to, when they come to the car, take out the key, press a button. Yeah, they just walk up to the car, pull the door handle, and the door opens automatically. Go into the car, push the start button, and the car turns on. And your key has never left actually your pocket. These systems are different in their realization, so they use challenge response authentication without user interaction. Basically what happens in a simplified way is the car, when you come near to a door, it will see with some movement sensor, so okay, somebody's in front and wants to open, will send out a nonce via 125 kilohertz link, which is quite low range, yeah, so meter maybe or 2 meters. And the key will then compute a cryptographic response to that nonce and send it out via its 433 megahertz link over high range. Yeah? So what is the weakness in that system, assuming the crypto is perfect? The weakness is there's no user interaction. Yeah? So anybody who is able to send such a signal to my car key can just get a response. So what we can do is we can just relay the low-range 125 kilohertz link, and the high-range link usually nobody cares about to relay it anyway, because there's like range of 50 meters. So you just extend maybe the way from the victim who has car keys somewhere behind his house door to the car parked in front of the garage. Yeah? And here Andres has made, together with Dario, a very nice documentation, demonstration how easy this can be. That's a relay now, so it's a cable. And he has basically extended the range. It's very happy from the key in Andres' pocket to the car, opens it, and now can drive away. Of course, this cable is just a joke, yeah, to demonstrate that it's possible to extend that link in such an easy way. Normally, it would be a high-range RF link. Yeah? So you have two attackers. One attacker is at the victim. One attacker is at the car. Attacker at the car picks up this wake-up nonce, pulls the handle, gets the nonce, relays it over long-range HF link to the other attacker who has the key. He will relay it, and then you get the response back, and the car opens. It's again looks like an obvious attack, and yeah, it was known since 2010. There were always some rumors that it's used also by criminals actively to steal cars, and recently, finally, I could find some documentation about this. So this is a court judgment from 2016, where some guy was sentenced to jail because he stole 21 cars using these relay attacks. Yeah, so sorry if you don't speak German, I will just highlight the key points here. So he did 21 cars basically on this keyless go, passive keyless entry things. And he used this thing that is called Mobi Finder, yeah, that does this relay attack in a much nicer way than the cable or what we built. Yeah, so he basically, they call it here repeater. They use he uses relay attacks to really steal cars. So this is a big thing, and manufacturers are working a lot on fixing that issue somehow, because in contrast to what I will talk about, you cannot fix it with crypto. You have to fix it in a different way. Yeah. Okay. One last thing I want to mention in the related work that also came up like round about one year before we published this one are so-called roll jam attacks. Has anybody heard about them? Roll jam? Never? So it's basically, I will not go into details here, it's a form of clever jamming where you can then reuse old codes. The thing to know about this roll jam attacks, usually they don't allow you to change the function of the button. Yeah? So if you apply this attack to a signal that was a closed signal on the car park, you can close the car again. Whereas in our attacks, you can open, close the car, do whatever, change the button function here. So these roll jam attacks have to be taken with a grain of salt. They can work in some systems where the button is not authenticated, basically. So we asked ourselves, we're now in 2016, so how secure are these keyless entry systems? We now come back only to the opening thing, yeah, nothing about this relay attacks anymore and so on. And when looking at our favorite picture here again, you sort of can see two things that can be done cryptographically. Yeah? So what can you attack here? One thing is you can target the way actually these cryptographic secrets are put into the car and put into the remote control. And secondly, you can just try to, probably the more difficult thing, you can try to attack the crypto. So you can try to do mathematical attacks. Yeah, sit in your room with a pizza under the door and work on this mathematical attacks and try to break the thing just by looking at the bits and bytes that are exchanged. And we actually found, conveniently enough, examples for both attacks that are absolutely realistically possible. So first example is the VW group system. And does everybody know VW? Yeah, German car manufacturer, big group comprised by VW, Skoda, Seat, Audi, plus some other brands like Bugatti. Does anybody have a Bugatti for research purposes for me? I'm still one, or a Porsche. Who I will try to, the remote control will probably still work afterwards. Yeah, so now we have not looked at these luxury brands for this reason that nobody basically has such a car for testing, whereas the VW is very easy to find in Germany for testing. So VW is always battling with Toyota, who is the biggest company in the market. They have roundabout with their group 10% worldwide market share. They had also issues with the immobilizer system called Megamos. Maybe some people heard that. It was a court thing that went on for a few years when Flavio, who also worked on this paper, published their Megamos algorithm and then got sued for it. And in the end, they settled somehow out of court, but it was a quite complicated procedure. Anyway, this RKE system has nothing to do with this Megamos. It's completely a separate system in a separate chip, basically. It's also fully proprietary and was used in sort of, you can see some revisions over the years between 2000 and today. So you can see like maybe here it says 4 main schemes. There are a few more minor variations, maybe 7 different schemes or so that they have used over the years. Yeah? So if you have VW that is before the Golf 7 generation, it's very likely you will have one of these 4 schemes or something similar. So how do you go about when you want to analyze these systems? So step 1, okay, we need to see what comes actually out of this car key. Luckily, that's very easy. So you can just get nowadays these DVB-T sticks, which work like a very simple receive-only software radio. Highly recommend that. Or you can get such an Arduino board, which can then also transmit. So we always used a variety of tools, and it's widely available, extremely cheap if you want to look into it. And then what you get after doing demodulation, you will see something like this. Yeah, so you get a sequence of 1s and 0s, and somehow you have to make sense of that signal. But as I said, it's a proprietary black box signal, so at some point when staring at the bits and seeing some random stuff happening, yeah, you don't get any smarter, so we went to reverse engineering, and because it's usually easier to go to the ECU side of things, rather than going to the proprietary small 4-bit microcontrollers in the car key, we got ECUs. Good source is eBay. When you order an ECU on eBay, you get this, yeah, Staropramen, a very nice Czech beer factory. So if somebody's already thirsty now again, probably, open it and you get some foam, some heavy oil comes out sometimes from the workshop where they do this ECU stuff. And then in the end you find an ECU. In this box, you can take it apart, take off the plastic case, which is always annoying. These things are really sturdy and built to last in your car. And then you have somewhere here the main microcontroller. And interestingly enough, from the car tuning area, from the chip tuning people, they're very good programmers for automotive ECUs, so you can read out firmware quite easily from these devices. And then you have the boring part of it, a lot of time in IDA to reverse engineer these firmwares, which are for some horrible proprietary microcontrollers that you have probably never heard of unless you have been in the automotive world, some NEC chips or whatever. And you can find the crypto eventually in there, which is not a fun thing. There's some documentation or more detailed documentation on this topic in the context of this Dieselgate thing, where somebody actually reverse engineered the complete functionality. Was at Chaos Computer Club last year, I think. So if you want to get into this topic and are interested there. So we repeated that for actually all 4 schemes, and then found the cryptographic functions and found quite a strange mix. So this VW1 scheme is really crypto from the 80s, linear feedback shift registers. You don't want to touch that, yeah, and it's an ancient thing, to be fair. Yeah. So was maybe at the time a thing to use as LFSRs. The VW3 system is quite interesting because it uses a proprietary cipher, which we later found as a rough description online, and that's why we know the name, Auth64. It's a block cipher, which is quite special, yeah, because it uses the key, forms the S boxes in the cipher and so on, and actually part of the S boxes and permutations are key dependent. But we didn't find now any trivial attack on this, but luckily we also did not have to, because the used encryption key here, K3 yeah, for key in scheme 3, is actually the same in all vehicles of the type VW3. So you see, like, one Golf is manufactured, puts the same cryptographic key in, next Golf puts the same cryptographic key in there. So we don't have any key diversification here. Any VW3 key or any VW3 car has exactly the same secret in it. So you have it once, you have it for all. There's also VW2, same cipher, different key, same key management, if you want to call that, or distribution. And it would be, yeah, even interesting maybe to look at the mathematical security, because this, as I said, this Auth64 cipher is quite weird and quite old, so it's a bit fishy. It could be interesting to look at it. In VW4, the problem of the cipher was actually solved, so it uses Xtier. Do people know Xtier? It's quite a nice, secure cipher with a large key, similar in security to AES or so there are no cryptanalytical attacks really known here. But again, it has the same cryptographic secret everywhere. So our job was quite easy. So basically, you just get these 4 keys if you want, or these 4 schemes. Then you eavesdrop one signal, and from there you can decrypt, increment the counter, re-encrypt, and so on. Yeah. So you basically create a clone of the remote control by just getting a single code somewhere on the parking. And now comes always the most interesting slides. Now, can you find your car in this slide? So there are many cars that are using one of these 4 systems. Here is the list. In summary, there are probably most VW Group cars between 2000 and today, except for MQB, Modularer Querbaukasten, yeah, horrible German word, means Golf 7 platform. So if you have a very new Passat or very new Golf, then you're probably fine. They claim they diversify keys. So unfortunately, I could not bring my VW, even though it would have fitted here. So we had to take a video for the demonstration. That's an older Passat, which has this VW2 scheme. So we just take a typical scenario. Somebody opens and closes this car, but just could be closed on a parking lot. Yeah? Now, like any good magician, we leave the key here. And our highly advanced eavesdropping device here on the Brett board has eavesdropped, and now we can just decrypt the thing, increment the counter, and have basically a clone of the original remote control. Yeah. So now we have done open, close, done some funny stuff in the car. So the car is now 4 signals ahead, right? So how many times do I have to press the original remote to so that it works again? 5 times, the answer is on the screen. Yeah, so you have to get to the value that was there before +1, basically, and then the remote works normally. So if this ever happens to your car, you should be a little suspicious and document that situation. Summary here. So the cryptographic algorithms have improved over time for VW. So we have seen this LFSR to Auth64 to Xtier, but the key diversification has not been used at all, or any form of putting like good secrets into each remote control, individual secrets. So basically it's just a question of reverse engineering the ECU firmware, looking in the right places, getting these cryptographic keys, and then have a very scalable attack. where I could easily imagine that it could be industrialized, yeah, for people who want to steal your laptop from your car or so. So according to VW, they say this MQB, which I mentioned, doesn't have this problem because they have diversified the keys and have strong crypto as well. So it's an interesting question to look into that if somebody wants to do research in that space. Looking back at keylog, in keylog we had a similar situation. Once we have this manufacturer key, we can get the remote control key. So the situation is pretty similar. It looks worse because the key is sort of everywhere, but in keylog and in this case it was similarly easy to get to this master secrets. Yeah, so not much advancement. Okay, so it would be one brand. How about the others? Are they better? And the answer is quite easy. They're not much better in many cases. Here you have a selection of car brands that use the so-called HighTech 2 system. HighTech 2 is some also ancient stream cipher that has been repeatedly broken in this immobilizer context, and we sort of saw it also in the rolling code context and tried to find out, okay, how good is this? And brands include like Fiat, one Ford car, Opel, and so on. Opel, yeah, ex-Bochum company. So what is the contribution here? We black box reverse engineered the protocol, and in that case that was actually without any hardware reverse engineering, just by guessing how could it be implemented. And it's actually done in a quite sane way, yeah? How you would do it if you were given HighTech 2 and somebody said make a rolling code system out of it. It was trial and error and knowing the cipher and knowing the inputs, guessing just the implementation. Second more important part, the previous attacks on HighTech 2 in the immobilizer context needed 136 protocol traces, yeah, so 136 pairs of input and output actually. And that's not really practical in the context of keyless entry systems. Yeah, so we said we need a better attack. We don't want to sit on the parking and wait 136 times until somebody has opened his car. So that's the second thing. I want to briefly show you this protocol. It's done very similarly to VW. The only difference, or actually two differences here are one, you have diversified keys. So the car is like a table with an ID of the key and of the car key and the respective cryptographic key and the counter. And then for your partner's key, for instance, you will have a different cryptographic key. Yeah, so that's good, diversified, fantastic. That's what we wanted in VW all the time. Secondly, they do not do this encryption. They do it actually more correctly. They use the cipher like a Mac. So they put all the data, UID, button, counter value into the cipher, run it with a specific key, and get a MAC tag essentially out of it. And at the end is a CRC that is not really important. So how is this MAC constructed? HighTech 2 is a stream cipher. So it's basically just 32-bit of key stream when you initialize the cipher with the UID button counter key in a very similar way. If you're interested in the details, look into the Usenix paper. So what we really get here is we get some input to the cipher. It's not all of the input because I left out some minor details, so we don't actually transmit the full counter, but only the lower 12-bit of it and so on, but that's guessable. And then we get this MAC tag on it here, so we have input, output to the function to an approximation. So, and we want to be obviously better than 136 traces. So what the new attack sort of in a nutshell does is, it can do it with round about 8 traces, which means 8 key presses, yeah? And this you can collect, for instance, with this Arduino board that I mentioned. Can just sit somewhere in a parking, grab all the signals. When you come in the morning, you press once. To close your car, you come back in the evening, you open your car. So you have 2 key presses per user per day. So round about after 4 days, you have your 8 signals, if you would put it on the university parking, I guess. People will always try here to park in the same spot if that would be possible. Yeah. You could even do something a bit better. You could just jam the CRC, and then the car will say, okay, it's an invalid signal, but all the remaining data has already been on air, so you can collect that data. To the user, it looks like, oh, my car does not open. So what is your typical reaction when you When your car does not open, try again. Does not open, really, try again. Really, try again. And then at 8, you stop jamming, and then it works, and everybody's happier. So then you can do that in an active way, speed that up. So I will not go into the complete mathematical details of this attack. I will sort of give you a flavor just of the attack, how it works, because it's late. I know everybody wants to eat, drink. I also. So anyway, that's why I will do it in a quite graphical way without giving you all the details here. That's HighTech Tube. And it's, as I said, a stream cipher initialized with this stuff that is written down there in the formulas. And to make that a bit more clearer, I'll actually put it up here. So the ID is written into this cipher, and the key initially, part of the key, 16-bit of the key. Then the cipher is clocked, and the other data is shifted into it. So actually, the IV, which includes this counter and this button, and some feedback due to this feedback function that you two see there at the top here. So the idea of the attack is now as follows. It's a correlation attack. So if somebody's familiar with that, it means it's statistics, and you need to do it over multiple traces, and the more traces you have, the better. That's why you need actually at least 8 traces here for the statistics to start working. What you do is you basically guess 16-bit, which was this upper part, and you do that for multiple traces and for each bit of the output, this key stream you have. Now what you do, you fix one guess, and for each guess you will guess in addition all the inputs to this function, just these input bits. Yeah? So you will get some predicted output bits based on this. And you can, of course, count if what you predict agrees with reality or not. Yeah? So you can see, is it a 1 or 0? Then you shift the same thing again by 1 position. You will get again like some agreement if it agrees or not. Do that again and again. And eventually also the bits that you have to guess there will change all the time because you shift this window through the cipher. So that changes a bit. So it's actually quite annoying to implement this attack because of all this bit fiddling and so on, but you eventually get there. Once you have done that, you will actually, to summarize it, get a list of all your guesses scored by the probabilities that's actually the correct guess. So you get a large list, and after the first run of this attack, you will actually not have necessarily the correct key candidate at the top. So you extend the window now by 1, do the thing again, and so on, and always discard the lower part of the list. So you can imagine it that after some iterations, the correct key candidate will sort of bubble to the top in this attack. As said, for details, please look into the paper. It's also more Flavius attack, so I'll just give you a high-level view here. What it comes down to, you run the stuff with an optimized implementation in roundabout 1 minute on a standard laptop and get the cryptographic key. So you need these ingredients, 8 inputs, and you run this attack, and you can clone the key again. So here's the end-to-end demo. There's Flavius' car parked there. So here we collect these 8 key presses, and you see on the screen up here, signals pop up. Now we have to speed it up a bit because it's quite boring to sit there. Yeah? Now just we run the attack here on the laptop. You see output of the correlation attack where all the sorting happens and this scoring and so on. And eventually, now, after 1 minute, you will get the correct key. Now, don't look, we have to black it on YouTube, cryptographic key. And afterwards, you can program that cryptographic key into this emulator now, in this Arduino board again, and it behaves like the original car key again. So we're at the same situation as we were with VW, just with a different way. Here we attacked the crypto, other one was key management. So if you're, again, interested in whether your car is secure or not, you can check this list. There was some mistake in the paper, which is fixed here, because sometimes it's quite confusing who resells in the automotive space to whom and so on. So interestingly, there's still 2016 model year cars in this list, which uses cipher from somewhere out of the 90s, out of the dark ages of crypto, where it was just hard to make lightweight crypto and where crypto was quite analytically weak. So if your car is in this list, again, consider it quite suspicious if you have to price multiple times when you come to your car. And then finally, actually, which we also found in one example is that some implementers did not get really this part with only into the future. So the way it works in some cars is you have a plus-minus delta. So you can also just replay old signals and it will still work as long as they're like minus 256 in, yeah. So that's of course really like implementation thing, and it's quite interesting how that could not be. I mean, did they never try to replay an old signal, or did that never happen by mistake? I don't know. I mean, it's not widespread, but it exists. So my unfortunate summary of this talk, at least until 2016, have we really learned from this keylog stuff, which was a big fuss in 2008? Not really. And what should we do about it, or what should vendors do about it? Here, Timo solves it like this. Yeah, his car doesn't have any electronic systems, and he has unsuccessfully looked for the OBD plug in the car also. He was a bit confused. That's also, of course, go back to the old days. Yeah. It's not very nice to do that to a modern car. And also when we did this research and thought about what should we tell owners of affected cars, it's a bit unfortunate recommendation that we can give for the current situation. Yeah, you can stop using your keyless entry system, destroy it, and use the mechanical keyblade again. That's not very realistic, and I think nobody would do that. So I have a Golf as well, and I always use that thing, even though I know how to break it. Yeah. Can also hope for a vendor to upgrade their systems, which is quite unrealistic because it needs an upgrade of all car keys and all ECUs and all VW cars, or all cars that use HighTech Tube and so on. So that's also very unrealistic to happen. It would help a bit in this HighTech Tube case for reasons that I've not fully explained here, to just randomize this counter value and start at a random location, but also, yeah, only a tiny bit. Probably the best recommendation is do not leave your valuables in your car. Do not leave your laptop in the trunk, and try to always take the important stuff that counts with you. Yeah, and in general, if you see the stuff where you have to unlock multiple times, that should be quite suspicious. Who actually can fix it and will eventually fix it, or maybe is working on fixing it, or has fixed it in new systems, are manufacturers of cars. So for us, it seemed like a solved problem. Yeah, you use good crypto AES, you do proper key diversification. For instance, just when you in the factory, just put like the same cryptographic random individual value for one car into the remote and the car. Or you, when learning a car, you just send the cryptographic key via this immobilizer interface once at the very beginning, and you're good to go. Yeah? There exist products that realize such functionality, so you can buy these chips off the shelf, and I hope that automotive companies will upgrade in this direction. So a few concluding remarks between you and the dinner. We also did, of course, responsible disclosure, which is a very important thing in such cases. So we talked to VW Group already in December 2015, and NXP, who sells this HighTech Tube chips. So in contrast to the VW system, that's used by multiple manufacturers because you buy it off the shelf from NXP. And in general, we had this time a very good experience, so we had a very good communication flow, and nobody threatened to sue us for it or so. Especially also because they sort of already have solutions in place. Yeah, VW says, okay, in MQB it's fixed, which, as I said, remains to be seen. And NXP and others for a long time tried to sell the AES-based chips that do all the stuff that I just mentioned on the last slide. So to conclude here, yeah, it's unfortunately, as I said, feels sometimes like a bit recommendations also from the 90s, because we should all have known that by now. Don't use bad crypto, and by even no means ever put a manufacturer global key into something, whatever. Yeah. So you will never be able to fix it, and it can leak in a million ways, from reverse engineering to unhappy employees to whatever. Yeah. So it's just a bad design practice. Still, finding that in 2016, as I said, was quite surprising for us. What is interesting from a point of view of insurance companies, for instance, there were these cases also where people said, my laptop was stolen from a locked car, and definitely there were no signs of forced entry. So how insurance companies handled that usually said, okay, you took your laptop, insurance fraud, we'll go take you to court now. And I think in the light of these findings, you have to, or this stuff will be taken with a grain of salt. Yeah? So if your car is in this list and you experience that, then you could definitely claim that it was car theft using methods as explained here. So my conclusion, yeah, Ihr Fahrzeug ist kein Tresor. Your car is not a safe box, still holds. And one final funny remark, there's this video, the paper is called Lock It and Still Lose It, and there are some US campaigns called Lock It or Lose It. So that's some pun on it, and these videos are really, really hilarious and annoying, and I always have to step back from not using them in my presentations and make too much fun of them, but definitely you should watch these videos as well. Just type Lock It or Lose It into YouTube and see some interesting videos that also, and then think about this research here. So thank you, I hope that was interesting and a bit outside this maybe space that you normally do, so you notice there's a lot of this hardware presentations here because many people from Bochum or who used to be in Bochum do this kind of research. Thank you and have a good evening.